doing both of these today.
We are. So just chill. Okay, so the zero product property, I'm going to repeat it. If A times B equals 0, then either one of the numbers or the other, or possibly both, have to be 0. Because that's the only way you get 0 for an answer is to multiply by 0. So that's what we're going to use today with our factoring to solve these. Okay, so on number 1, the difficult thing is we're going to have all the different kind of factoring. So we're going to kind of review that as we go. Okay, so if I have this, if you look at the setup, there's no number in front of the x squared. I have a quadratic trinomial with no number in front of the x squared. So those are the ones that we set up with the little x puzzles. It multiplies to make 8 and adds to make -6. So that would be...
Does it matter that they have a greatest common factor? Or am I just remembering something?
This one doesn't, so later it will. So this one doesn't have a greatest common factor, but I'll talk about that when I get there. Okay, so the numbers that make this work are -4 and -2. We multiply them, we get 8. We add them, we get -6. So when we factor that, we're going to get x minus 4 and x minus 2. And notice we now have an equation. It's equal to 0. Okay? So I'm going to box off my little puzzle over here so it doesn't get in the way. So either this little group or this little group has to be 0 when you put x back in there to get 0. So we do to figure out what x is you set each of these equal to 0. X minus 4 equals 0. And x minus 2 equals 0, and we solve those very simple equations. So over here, we'd add 4. We see that x is 4. That's one of our solutions. Here we add 2. We get x equals 2 for the solution. So the only thing that's changed from what we did with all the factoring is that's it. We now have it equal to 0, and you just take each factor. We call it factoring because we're making these into factors, things that multiply together. And then each piece gets set equal to 0. Okay, so let's look at number 2.
But then which one of them is 0?
Either one of these could be the answer. So you get 2 answers. Whoa.
But one of them doesn't have to be x equals 0.
So if I put 4 in here, I will get 0. And if I put 2 in there, I will get 0. Both of them are solutions to the equation. And you could try that on your calculator and check. 4 squared minus 6 times 4 plus 8. Or you could do it in your head and convince yourself. But both of these would give you an answer of 0. So when we add that power, that second power on there, we end up with more than one possible answer. Okay, so let's look at number 2. Now, number 2 only has 2 terms. The first thing you should always look for is if there is a common factor we can take out.
No. Yeah, no.
There is an n we can take out. So not a number, but there's an n. So we could take an n out of both terms. So if I do that, what do I take times n to get n squared?
1.
N. N times n makes n squared. And what do I take times n to get 5n? 5. So we still have 2 factors. On this one, there's not much to solve for. It's just n. So either n is 0 or n plus 5 equals 0, which would mean, if we solve it by subtracting 5, that n is -5. So if I put 0 in there, 0 squared plus 5 times 0 would be 0 plus 0, which is 0. If you put a -5, I would get 25 plus -25. It also equals 0. So both answers work. All right, let's go down to number 3. This one has the 3 terms again, so we can do our little puzzle. It multiplies to make 4, adds to make 5. So it'd just be 4 and 1. So I'd have v plus 4 and v plus 1, and then it equals 0. The 0 part's important because otherwise this wouldn't work. So we're either going to have v plus 4 equals 0 or v plus 1 equals 0, and then you just solve those. So subtract 4 on the first one, we get -4. Subtract 1 on the second one, we get -1. So it's just adding a little bit to what you've been doing. Okay, so on number 4, same kind of equation. We've got the 3 terms, squared term, linear term, your quadratic term, linear term, constant term. So we're multiplying to get 64, adding to get 16, so that would be 8 and 8. So I'd have n plus 8 and n plus 8 equals 0. And you could write it n plus 8 squared if you want. So really, I'm only going to have to solve this one once because you're going to get the same answer both times. So we have n plus 8 equals 0. And so this one only has one solution, just because of the way it's set up. When we get into graphing our parabolas, we'll go in a little bit more depth on why some of them have 2 solutions and some of them have 1.
Yeah, it's okay. I didn't need to use glue.
Okay, so let's go down to number 5. There are no common factors to take out, and it doesn't have the 3 terms. So I check and say, does it have any other patterns? And I notice I could write this as b squared minus 1 squared. It is a difference of squares. Okay? Because there's that pattern that we learned where I just put it in parentheses, b plus 1 and b minus 1. There's that formula that we learned with the difference of squares.
Why did we put square? Oh, wow.
Just so I would, yeah, just for the format. And so then I would have b plus 1 equals 0 and b minus 1 equals 0. And we're going to get negative 1 and positive 1 for the answers, which makes sense. I mean, if you think about it, you put that in, you square it. Either one of those numbers would give you positive 1, subtract 1, you get 0. So you can check these by putting them back in. I kind of did these in groups. So on number 2, there's no common factors. It doesn't have 3 terms, but it's like, I'm sorry, on number 6, it's like number 5. I could write this as k squared minus 2 squared. So when I factor it, I get k plus 2 and k minus 2. So that's a difference of squares. So we get k plus 2 equals 0. K minus 2 equals 0, and then we just solve those. So on the first one, we subtract 2, we get negative 2. On the second one, we add 2, and we get positive 2. So we're getting to practice all these different kinds of factoring. Yay.
Lucky us.
Lucky us. It's good review since we got a test coming up.
Don't use those words.
Okay, so far we've looked at so we had a greatest common factor problem. We've had 3 of them where we use the x. We've had 2 difference of squares. We get down to 7 and 8, and I don't see any common factor I can take out. Doesn't have any special patterns where I can do the difference of squares, so we're going to have to do the slide divide bottoms up method. So we're going to take the 4, multiply it by this 4 over here, rewrite it. X squared minus 15x minus 16 equals 0. So that's the slide part. And then we factor using the x. So multiplies to make negative 16, adds to make negative 15. So that'd be negative 16 and positive 1. I don't know why I couldn't get that out. So x minus 16 and x plus 1. Now here's the part you don't want to forget. Since we slid this 4 down and multiplied it by this number, which is where these came from, we now have to divide both of those numbers that we came up with by 4 and then simplify any fractions. So 16 over 4 would simplify to x minus 4. And any fractions that won't simplify any further, like the 1/4, we bottoms up. So the 4 comes up in front of the x, and you get 4x plus 1, which is just a cool trick. And then remember that all of this is equal to 0 if we're going back to the original problem. And so then we'll have x minus 4 equals 0, which is a simple one-step equation, and 4x plus 1 equals 0, which is a 2-step, but still not too bad. So if we solve the first one, you just have to add 4. We get 4. On the second one, we would have to subtract 1, which would give me 4x equals negative 1, and then divide by 4. And we're going to leave this in fraction form, so you kind of get that when you put the divide by 4. Just be negative 1/4. Okay? So when they have answers that are fractions, those are the ones that are a little bit more interesting to factor. So we're going to do another one like that, and then I will throw a little curve at you, but it's not a big deal. It'll be okay. So on this, if we look, we don't have any common factors. I do have a term in front of the x squared. It doesn't It isn't one of my special patterns I can just do automatically. So we're going to do the slide divide again. So I'm going to slide the 3 down to the end and multiply. We'll get x squared plus 20x plus 75. And then we'll do our little x. So it multiplies to make 75 and adds to make 20. I think that's 15 and 5. Does that work?
Yeah.
Okay. So we'll have x plus 15 and x plus 5. What do I do now? Divided by 3. Since we multiplied this by 3 and that's where these numbers came from, I now have to fix that. Divide by 3. So 15 divided by 3 is 5. We can go ahead and simplify that fraction. This one doesn't simplify. We'll go ahead and slide that up. 3x plus 5. And then it equals 0. So I'll either have x plus 5 equals 0, which I'll go ahead and solve. Gives me -5. Or I will have 3x plus 5 equals 0, which is a two-step equation. We have to subtract 5 from both sides and then divide by 3. And I'm just going to leave it improper as -5/3. So it doesn't reduce. You could make it -1 1/3 if you want, but on most of the answer keys, they're just going to leave it like that. Okay, so that's the main idea. Well, if I don't show you this part, you'll be confused. The equation has to equal 0. So if there's something on the other side, you have to add or subtract to move it over. So if I have -1 here, I just have to add 1 and rewrite it. P squared minus 2p plus 1 equals 0. And then I can do the things that I would do on the other page. So this is one of the ones you could factor with the x. So multiply to make 1 and add to make -2. So that would be -1 and -1. So I'd have p minus 1 twice, or squared I should say. And so we're only going to solve that once. So p minus 1 equals 0. If you add 1, you end up with p equals 1. I think we can just do the odd problems on this page. I don't want to kill you guys. So I'm going to just focus on this left-hand side. I think that'll be enough. So on this, you always want your squared term to be positive. So I always move stuff from the right to the left. You could move it from the left to the right and then change all the signs. I don't know if that's confusing or not. But we want it to be in the right order. So I need to move all of this to make this 0. So I'm going to subtract the 11b, and I'm going to add the 30. And so the right-hand side will be 0, because we canceled all of that out. And the left side I'd have b squared minus 11b plus 30. You want to put it in the order with the quadratic term first, linear term in the middle, constant term on the end, so that it's in the order that we're used to looking at when we factor. And then this is another one of those that we can solve with the x. Quadratic trinomial with leading coefficient of 1. So they multiply to make 30, add to make -11, so that would be
-5 and -6.
good, -5 and -6. So b minus 5, b minus 6 equals 0. So either b minus 5 equals 0 or b minus 6 equals 0. And so,
Is it okay if I skip that step?
and just write, yeah, you can just go down to this if you can see it.
Okay.
I'm just trying to be thorough.
Yeah, I got
so
you. I'm just making sure.
if I skip steps, then I usually lose somebody. So I'm trying to be thorough, and so I'm showing all the plus and minus. But after you do a bunch of these, you're going to start looking at this factoring thing and go, oh, it's 5 and 6. Because you know 5 minus 5 makes 0. You know 6 minus 6 makes 0. And it just makes sense. Okay, so let's go down to number 13. So what do I need to do first? Subtract the 3, and it's going to subtract from this 39 since those would be like terms. So that gives us 0 here. I'd have x squared minus 12x plus 36. So it's another one of these. So we'd multiply to make 36, add to make -12. So -6 and -6. So I'd have x minus 6 and x minus 6. And we'll just solve that twice, or solve that once, I mean. So x minus 6 equals 0 will give us x equals 6. And then on the next one, to get 0 on this side, we'd subtract 4b. Which term over here would I subtract that from?
17.
The 17, because it doesn't have the squared. So it's tricky because they both have b's, so it has to subtract from whichever part has the like term. So then I would have b squared plus 13b plus 42, and then we can factor it from there. So multiplies to make 42, adds to make 13, so that would be 6 and 7. So b plus 6 and b plus 7, and we solve from there. So b plus 6 equals 0, b plus 7 equals 0. So we will get negative 6 and negative 7.
I feel like I can keep on